Hello, everyone, and welcome to this module that's whole building energy modeling. So we will be getting into energy modeling that's a little bit more maybe affiliated with a developed Revit model, or another way of looking at it rather than just a developed Revit model is kind of a developed point within the design process. So in beginning to do this and setting up our model for energy analysis, we need to make sure the model has the proper assumptions to complete an energy analysis run. So first thing we want to do is open up the whatever Revit project you're using, go to the manage, set up the position to true north, right? It's already been done here, so I'm not redoing it. Location, set up the location you're using so it pulls in the correct weather file. Again, that's all things we've been doing day in, day out in this course. And maybe the main differences then begin to play into the analyze. Actually, let me expand my toolbar so we can see everything. All right, so the first thing I'm going to do is I'm going to go into energy settings. And in the mode, I've got three options. Conceptual masses, which we've worked with before. Conceptual masses and building elements, it's kind of a merging, kind of hybrid of conceptual mass modeling and like actual detailed building envelope elements. But we're going to use building elements because you should have a complete Revit model. The ground plane we want to set to the lowest level of our building above grade. So this may vary if you have like a parking garage scenario in your project. The resolution, this is for the space resolution and this is for the surface resolution. It's essentially the threshold that if there's a gap and it's smaller than this quantities, it will just assume that it's okay, nothing to worry about. But if it's larger, then it will treat it as basically an error gap where, well, error can pass through it. A few things that begin to change on us is if I use conceptual masses, we see that I no longer have any options for the perimeter zone depth, because that will be defined by kind of the room boundaries. And then a few other things I want to adjust. We see that I have no settings for the detail, like these items listed in the detailed model, because all of these functions relate to the mass modeling and mass energy analysis. Same with all the material thermal properties listed here, like all these conceptual types don't really apply, right? Because they're all mass assumptions for those conditions. Same for the schematic, which is really those same ones I just brought up, the assumptions that are used. Or these will also be the, well, it says right here, from information conceptual types. So we're not dealing with conceptual, that doesn't matter. We want to check the detailed elements. And then the main difference, or the main thing to be sure to set up, is the export category will be rooms, not spaces. Spaces we will be doing in another module, but this one will be rooms. So that's what we want to be sure to use. Now for the building type, you want to set this to the type of building that's being used. Essentially, this tells the model what kind of assumptions to use for running the analysis. A very kind of easily readily available example is in an office, people are kind of sitting at their chair, they're not getting much physical activity, but in a, let's see here, let's say a warehouse, people are probably moving a lot more, right? So there's a greater need for air conditioning because people are increasing their bodily temperature at a greater rate. Therefore, we should assume a greater kind of quantity of air conditioned air entering the space. And that's why this building type is important to be sure to set up, because it relates to not only heating and cooling assumptions but lighting assumptions, because there's different recommended light levels for different kind of tasks, and it's just going to make all those assumptions based upon more or less what's called ASHRAE standards for energy modeling. And I can provide some links kind of explaining what the building type and operating schedule and all this is. Next is the operating schedule, and I think we worked with this before, but the item to the left is the number of hours per day, and the number to the right are the number of days throughout the week that the building will assume to be occupied. If I select default, it's going to pull whatever values are default for the building type. This is a school, so I'm going to set this to school. I'm just going to use the default operating schedule. The HVAC system, normally this would be kind of something that has entered the discussion around schematic design, design development. So we would plug in what the intent, like the initial HVAC system would be. I'm going to go with a VAV type system. VAV stands for variable air volume. And this 4-pipe fan closed system, that seems to be fairly common, so I'm going to use that. And these are the important things to set up for right now. You can change the operating schedule to whatever feels right to you, or you know is most accurate for the program you're designing for. For the outdoor air temperature, we're not going to worry about any of this, but there is a way to overwrite sort of the outdoor air per person and per area, and then the air changes per hour. Yeah, so there's ways to overwrite that, I guess, more in kind of professional practice and whatnot. But for right now, we're not going to worry about that. Okay, so we have all of our initial assumptions set up, at least in the analysis environment. That's a good way to explain this, is we're sort of positioning the analysis environment to perform in the most accurate way. We've got the true north orientation down, we have the weather file associated, we have the analysis assumptions created by selecting the building type right here. We have the operating schedule. We're telling Revit, hey, I want you to run a simulation based upon my modeled components. And that's all good. The final thing we need to do is we need to set up our room boundaries and the thermal properties of all of our Revit geometry. The first thing I want to point out is in the walls, because this will really influence analysis results. So if I click on what is a exterior wall, and I go to edit type, I want to make sure that the function is set to exterior. If I select this, we see that I have 2, 3, 4, 5, 7 different options. So if you have like a core shaft wall, you may want to change it to that, but the key here is to make sure that within your family, within your wall family, that we have interior and exterior properly set up and properly modeled. So all of my exterior walls should be on a family that has that exterior wall set, and if I select on an interior wall, go to edit type, I want to make sure that the function is set to interior. This will have a major impact on your energy model, so please make sure that is correct, what you want. Okay. After making sure that the walls are set up interior, exterior, then we want to set the thermal properties. Now we set the thermal properties with every item within our model. So are all kind of architectural elements. So walls, floors, windows, doors, roofs, skylights, all that. How we set thermal properties, so if I zoom in, is I select a roof, like so, and I go to Edit Type, click Edit, and we see that the resistance, like it's actually providing me with thermal resistance. This is what we're going to work on setting within the families. Now, after you set it, you want to be sure to do like a hand calculation to make sure that this is correct. I assume that everyone has taken physics at this point, so I'm not really going over like what thermal resistance is and how do you calculate for an R value. But if in the event anyone needs a refresher on how to do that, let me know and I'll provide some information. But otherwise, the thermal properties are material based. So if I select material within inside my wall family, we see that I have a thermal tab, and there I have all the thermal values. So I would, okay, so like let's say I'm looking at this EPDM roof. I could look at a manufacturer of EPDM membrane and then plug their values in for these different things so that it matches the product that I tend to use or the material, right? So I would want to do that for every single one of these layers in here. Even air can have a thermal property. And there's some default values that can be used, like if anyone has what's called the Mead Mechanical Electrical Equipment book, that has some great appendixes for thermal values of common building materials. But I mean, every building product, it's quite easy, I find, to obtain thermal values. So that really shouldn't be an issue. But let me know. Be happy to help. All right, so I would set all those up for the roof. If I go to like a curtain wall, select this thermal value is actually going to come from the curtain panel, as we see here. So I would, rather than updating it here, I would need to navigate down to the curtain panel family. Curtain system, double click that. Actually, no, I don't want the curtain system, I want the curtain panel. Curtain wall mullions. There it is. System panel glazed. That's what I'm using, and then I've got a material property for this. And then there's the thermal value that I would update based on the glazing. I tend to use this behavior of isotropic or orthotopic. I wouldn't really worry about. Basically, it's saying that the excuse me, it's saying that based upon the heat flow direction, essentially there could be a different thermal behavior. But we're going to use the isotropic method. And so just put in the thermal conductivity per hours per foot per Fahrenheit. That's that. And so like, let's see here. So if I go to, so I would want to do that. If I have elements that are maybe part of the facade but aren't really part of the enclosure system, right? I mean, there's accent materials all the time. Like this roof, for example, it's not really providing any kind of like real thermal benefit. So what I would want to do is over my properties, which says room bounding, I would just uncheck that just to make sure that the energy analysis is running correctly, because it's not actually enclosing a room, and I don't want Revit to think that there should be a room there, when in reality there isn't. So, okay, there's that. And just as another example, if I go to the entry level, I can select exterior door right here. Go to edit height. So in the door, I've got a material for the panel and the frame. A lot of this is going to be based upon how your families are constructed within your model and how the material parameters are worked in. But I would change the door panel to the proper thermal value. But we see that in this material, there's no thermal value set up, right? This is blank. But to add a thermal value, I click plus, thermal, and I can just pick any one, really, and I can just pick this arrow next to it. If there's one that's close to what you're actually using, like you can see that, let's see here, the frame would actually, well, a lot of these are blank for me because my library is kind of messed up. So I'll just go with the one I picked, just to kind of get it in there, and this is aluminum. But I can just update these values, like if I click that. Sure. See, there's literally nothing there for aluminum, so it doesn't really matter. But I can just update the values to what I know they are based upon my research, and that would be that. When you're updating these values, just make sure that you're working in something that is the same unit. If not, you may have to do some conversions, but we want to make sure that we're working in BTU hour per foot per Fahrenheit degree. Yeah, just let me know if any hands needed at all with that. But okay. So you would go through, assign thermal properties to every architectural element, I'll say, within your model. I mean, like stairs, for example, they don't need it. They need to be applied to anything that is creating a thermal enclosure, which is essentially walls, roofs, windows, anything that's in the facade, and anything that's really defining a space from floor to ceiling. Okay, so you would do that. And then you would be almost ready to run an energy analysis. What you would need to do, though, after setting all your thermal properties up, is put rooms in every location. So I just deleted that. But to add a room, if you don't know, you go to architecture, room, and then I can just drop one in here. There we go. Nice and easy. Now if I click on these boundaries, we can see that its limit offset is set at 8 foot. That's like the top of the boundary. That might be problematic. We shall see. If I do a section through it, and view, section, going too far over. All right. Now we stem this up. Okay, so far I'm not really seeing any rooms. If I go to edit visibility and rooms, You can check the interior flow and the reference, click apply. Okay. So we can see that between my ceiling and between my room boundary, that's what this is, there's this white space. It's no good because we want this to go all the way up to the thermal environment. So I'm just going to make it go a little bit above the ceiling, and you can adjust this by clicking on this and then either setting the limit numerically. So if I did 8'8", click apply, it just gets me there, or I can just grab this edge and drag it up. Either route works, but we want to make sure that it's fully enclosed. Actually, I would even recommend just taking it all the way up to the underside of the floor above, and same with this. This is going a little bit above the ceiling, but I would just take it all the way up to the roof. Just make sure that it intersects, because I have this set to room bounding. Like, Revit will understand that the limits of the room will stop wherever it encounters any of this geometry that says room bounding. Same thing with this ceiling. So it's smart enough to figure that out. So we would want to do that. I think, let's see, if I go back to floater, there's a few different ways to handle stairwells. You can either define the whole stairwell as like one room, or you can I'll do another section. I'll just rotate this one. Or you can define it based upon each kind of level, more or less. It's up to you. I've done a little bit of testing and I found the results to be nearly the same, but the key is, like, we can see how I've got these gaps between these rooms. That's not what I want, and that's why I find it easier, actually, to, rather than just having like a bunch of rooms and a stairwell, I just have one that just continues all the way like this. So it goes from the floor up to the roof. It works pretty well. So I've gotten into a few situations where I had like a kind of like an angled stair, and then I had to create two rooms to get the energy model to work. But that's something that could come up, so be mindful, I guess. And yeah, there we go. Let me think. That's it. We have everything set up now for energy analysis, and I realize it's going to take some time because you got to, get all the material properties set up. You got to get all the rooms going. But once that's done, I can go to a 3D view, and in the 3D view, I want just my building, no sites information or anything, just the building. And I'm going to delete my previous energy model, but then in doing so, will take me to this. I can select generate, create energy analysis model. Just like we've done before, we've created energy analysis models. And then it's just going to take a few seconds to run. I think it's going through and defining everything. It's taking a bit longer than it normally does, but that's how it goes sometimes. And while it's doing that, I'll just go over the assignment. So the assignment I have right here is whole building energy modeling 1. For this assignment, you'll essentially just be running an energy model through Revit. So you define the rooms and boundaries, define the thermal properties, define the simulation criteria, which is what type of building it is, run the analysis, and then create 3 scenarios for performance improvement. For the scenarios, I'm really expecting you to just look at different like scenarios within Insight. Okay, this is just taking a while longer than I expected it to. So I tried it and it just ran, but that's okay. Essentially, what you do though, after you have all of your everything set up, you just generate, and then it will send a. Actually, you can click generate, and then it will send the energy model to Insight, like we've done before with the mass modeling. And then if you open optimize, it will open Insight 360. And so I already have this from when I ran it previously. So here it is. Actually, it's older, but room-based analysis. And there's the energy analysis model that Revit is preparing for me, all ready to go. And we can see all the different scenarios I've looked at. So I don't believe I've saved any of them, but you'll be saving, what was it, 3? So there's that. Don't forget to set your units to what you want to look at, whether it's United States dollars, essentially currency, or energy use intensity. I'm going to look at energy use intensity. And if I look at like roof construction, like the triangle is the BIM model, that's information that came over. So it looks like I'm already getting a pretty good energy performance. At least there's no default values that could beat it. I could always create another assembly, remodel this in Revit, rerun it, and then see how it handles in terms of improved energy use. But I mean, all this is things you've been working for. I would stay away from like orientation and whatnot at this point, because theoretically at this phase in a project, if you're really defining assemblies, you're not going to be looking at moving the orientation of a building. But we may be looking at, okay, like what kind of glazing strategies, right? Single glass, double clear, double low E, triple low E. Looks like I'm already, best savings there. Same with this. HVAC system. Oh, yeah, see, I could use a packaged thermal heat pump. That's going to save me some energy. So that would be a scenario to look at. Right? Do that, and then I could. Okay. That would just, save the scenario. Oh, yeah. I think it's giving me problems because I'm like running the analysis over here, and it's getting a bit of a hang up. Okay, process complete. Oh, try it. Signing in. Okay, anyhow. I think everyone gets the idea. I mean, I went through how to set up the energy model using the detailed components, how it's connected to R value, how we set up the assumptions, how to push that all to Insight, using this kind of more detailed way of conducting energy analysis and modeling. So let me just 3D energy model. Thought this was set up. Oh, okay. Didn't actually create it. So I didn't create it because I wasn't signed in. Please be sure to sign into your Autodesk account so you don't have problems like I just encountered. There you have it though. And yeah, again, create scenarios, just click on this. This would be, I can rename this. So, there you go. And that's what my energy analysis model looks like. I can even click on these individual surfaces, and actually what's really interesting is if I can just click on these layers, click on the heating mode, and then I can see like where my greatest heat loss is. These. Click on this, and it actually tells me the density per year that I'm losing heat to. Same thing with the cooling loads. And then if I really want to be interesting, I can explode the whole thing. So it expands out, and I can really get a nice look at what's happening in terms of programmatic use and energy consumption. It's all very useful. I can also do a section cut through it if I want. I mean, there's all kinds of like set up camera interactions, zoom, pan, what have you. But I find this is this kind of explode option is very useful when I'm maybe looking at how does the program and material properties of a building impact energy use. Because to not much surprise, but all this glazing is requiring a lot of cooling. So it's like, maybe I would try to break that up a little bit or look at other strategies of refining that. Yeah, so there you go. Yeah, so again on the assignment, just spend time really setting up the Revit model correctly and accurately. I use correct, but that's not really the right word. It's using the best assumptions you have, and then run it through Insight, make some comparisons, analysis, identifying areas that you could really improve the performance of your building for. So, okay, good luck to you, and yeah, let me know if you have any questions or any issues. I'll be happy to help you work through them. Another thing too that maybe I didn't make enough of a kind of okay, Revit's tracing up, but when you're adjusting the material properties for the thermal values, they can literally be anything. I've had someone that used like rammed earth before, so we did research on like where does the thermal value of rammed earth and how do we really get Revit to account for that in the most accurate way using energy modeling. So please know there's no like real limitations on using the energy modeling process. I've went over. The only limitation is know-how, and that's what I'm happy to help you with, is the know-how to conduct these energy models. So just let me know, and I will talk to you later. Thanks. Bye.